Welcome back. So we are now going to see how to go about building a random forest model in Python. I have already launched my Jupyter notebook. The file randomforest.ipython notebook is available on our LMS. Step 1, we are going to import certain libraries. I require OS, pandas, numpy, matplotlib, sklearn.model selection, collections, basically order dictionary, and random forest is an ensemble modeling technique by itself, so it is available in sklearn.ensemble. So we require a random forest classifier. So we'll run this and import those packages and libraries which we require. Step 2, I'm doing os.chdr. I'm setting my working folder directory where my data file, dev sample and holdout sample. Dev sample is our training set, holdout sample is our testing set. I have myself done the train test split. Typically what will happen is you will have the entire data. When you have the entire data, what you have to do as a first step, split it into train test. You have to create the two data sets. Thumb rule is 70-30. If you have sufficient number of data points, in that case, you take 70% of data points as training sample, 30% of data as your testing sample. In our case, we have got 20,000 records. So I've done 70-30, 14,000 is my dev sample and 6,000 is my holdout sample. Holdout sample is your testing sample. So we are going to set the working directory and load the two data files. Having loaded, I'm now going to see how many records are there. So I do a print. The moment I do print, it shows me there are 14,000 and 6,000 observations. Let us quickly do head function on our dev sample. On head, I get sample number of records. Let me put 10 here. If I would have put 10, in that case, I will have 10 records showing up. Yeah. The dataset is of a banking problem statement. Let me just quickly say what is the banking problem statement. Bank executed a campaign to sell personal loans to their customers. They gave an offer saying that we offer personal loan at an attractive interest rate of 11% per annum. If interested, SMS back yes on a short code 55855, something of this kind. Customers who have responded to that offer are marked as 1 in our dataset. Those who did not respond are marked as 0 in the dataset. So basically my target column is my labeled class column. If you have a labeled class in your dataset, it becomes a supervised learning algorithm. And random forest is a supervised learning technique. To predict the phenomena of interest, you require certain attributes. Those are called independent variables. My independent variables in this case are age, gender, balance, occupation, number of credit transactions, age bucket, score, and holding period. Certain attributes like age, gender, occupation are your demographic attributes, and there are certain attributes like balance, number of credit transaction, score, holding period. Those are your behavioral attributes. Using these attributes, I now want to predict which customer is likely to be 1, which customer is likely to be 0. So we now use this to build our model. Before I get into the model, typically what you have to do is you have to do an exploratory data analysis. You have to do a descriptive statistics of your various independent variable to understand how many males are there, what proportion of records are male, what proportion are female, what is the average balance, what is the min max balance, is there outlier in my data, are there missing values in my data. If there are missing values, we have to impute it. If there are outliers, we have to treat it. For now, we do not have to do some of these treatments. For example, outlier treatment is not essential in case of a classification tree technique. Why it is not required in case of a classification tree technique is because when you split a data, a node, when you split a node into two child node, assume you are splitting based on a variable, say balance. The split would be balance less than 10,000 and greater than equal to 10,000. Now, if there is a particular record where the balance of a particular customer is 10 crore 50 lakh, which is an extreme value. But what are you saying? There is a two node, one node is less than 10,000, other node is greater than equal to 10,000. Now, greater than equal to 10,000, you are not bothered whether it is 1 crore or 10 crore. You have clubbed all of them together. As such, a classification technique is not impacted by outliers. And random forest is just an extension of a classification tree technique. As such, random forest is not impacted by outlier. Outlier treatment is not essential. However, if there would have been missing values, we may have to treat missing values. For now, in our data set, we do not have missing values, so we need not bother about it. And anyways, outliers, we need not bother. Okay. So let's move forward. However, the point I'm trying to say is descriptive statistics is an essential step that you should do. But we are now focusing on random forest technique. As such, I'm skipping all of those steps. We need to now understand what is the distribution of our labeled class columns. How many ones are there? How many zeros are there? So I see in the overall data that is available to us in the development sample, 91.17% of records are 0 and 8.8% records are 1. Just for our understanding. Given the data is 91 is to 8.8, this kind of a split, I can say this data set is an unbalanced data set. We need to now create our data such that we have got all independent attributes as X and my target variable as Y. So here what I'm doing is from the overall data set, I'm splitting the features and the response variable. Age, gender, balance, occupation, all of these variables are attributes which are features. So I'm putting it in X. Again, gender has got levels, male, female, others. I need to convert these categorical attributes into dummy 10 matrix. I need to do one hot encoding. So when I run this syntax, get dummies, what will happen is all categorical variables will get converted into 10 matrix. Okay. I am now in this step separating out the target column and putting in one column Y train. So here you can see we are creating X training set and Y training set. X training set is all independent attributes. Y training set is my target column. This print xtrain.columns has given me this outcome. If you see the gender, what has happened to gender? It has become gender underscore F, gender underscore male, gender underscore others. If you see the age bucket has become age bucket 31-35, age bucket 36-40, and so forth. They have been converted into columns. Okay. Basically, this is my data set. These were my categories. Now these categories have now become column names. This is what we are doing by one hot encoding. Let me try and show a sample data. So here I have now executed xtrain.iloc. I'm just showing the first record. You can see this first record now has got columns age, balance, number of credit transactions, score, holding period, and gender is become one column is now become three columns. Gender underscore F, gender underscore male, gender underscore others. I'm going back on the top screen. My first record was actually a male, which means out of the 3 columns which have been created out of gender, the column which has got gender underscore male will be marked as 1 and other 2 columns will be marked as 0. Likewise, occupation has got converted into the 4 occupation categories. Those become column. Depending upon whether the person was self-employed, salaried or what, if it was self-employed, that will become 1, otherwise it will become 0 and so forth. So basically, when you're building these machine learning models, and specifically when you are using sklearn for building your machine learning model, sklearn package does not accept categorical columns. Categorical columns has to be converted into dummy 1-0 matrix. And random forest, if you recollect, we are using random forest classifier, which is from sklearn.ensemble, which means I cannot pass any column which is categorical in nature. That categorical column has to be converted into dummy 1-0 matrix, and that's why we had to have this step. I hope this makes sense to all of you. Having converted all of this, we now create our classifier object. So here I'm creating my classifier object. Now we are going to create our ensemble classifier. I have taken this code from skykitlearn.org, where they have given the code to build a random forest model. I have customized that code. So here I'm building one random forest classifier object and I'm giving the name as CLF1. Okay, so let's run this. Let us understand these attributes. Warm start equal to true. What is warm start equal to true? Here there would be some internal parameter which would be saying how many trees have to be created in the background. I do not know what is that default number. That default number maybe say 501. Now we have to build 501 trees. Warm start equal to true means what? I build a random forest model. In the first iteration, I'll have only one tree. I'll see if I build a random forest model only having one tree, what will be my classification accuracy, or what will be my classification error. This classification error is called as out of bag error. Why it is called out of bag error, we'll see shortly. Then I will build a random forest model with 2 classifier tree in the background. Now to build a random forest model with 2 classifier tree in the background, I am saying make use of the first tree which was already built, and now you construct one more tree. Now assuming 2 trees are there, what will be your out of bag error? Now I want to see what happens if I build 3 trees. If I build 3 trees, what will be my error when I take a decision with the 3 trees together? But now to build 3 trees, should I build 3 trees afresh? No. Already 2 trees are built, no? I take those 2 trees as part of my model and only one more tree is built, that is 3. This is called warm start equal to true. Okay, why is this essential? Because here what I am going to do, I am going to loop the random forest model from saying build 30 trees to 202 trees. So first time it is going to loop and build a random forest model having 30 trees in the background. Then it is going to loop and build a random forest model having 31 trees. I'm saying already take into account the 30 trees which were already built. So this is the importance of warm start equal to true. Okay, so here we have created the classifier object. Now here I am creating a ordered dictionary error rate object list. What it is going to capture? It is going to capture label and my error rate. What would be my error rate if I have only 30 trees? What will be my error rate if it has got 31 trees, 32 trees? So here I'm creating a map of a classifier name, which is number of estimator and the corresponding error rate. Now in this piece of code, we are doing a looping from 30 to 202. This is a for loop and there is a subsequent for loops. There are two for loops. This outer for loop is useful for this one. If I would have one more classifier object here with some different settings, if I would have one more classifier with some different settings, in that case this outer for loop would be useful. These multiple classifier objects are available in this path. The demo sample code which scikit-learn package has given, it is available there. I have not used those multiple options. I have used say only I want one classifier. Okay. And this inner is for my looping from min estimator to max estimator. Okay. I'll run this piece of code in background. Now my code is executing, building a random forest model having 30 trees, building a random forest model having 31 trees, building a random forest model having 32 trees, and so forth. It is going to take some time. Let us see the out of bag error rate versus estimator. Let me just plot out of bag error rate versus estimator, and now let me explain you the concept of out of bag error. What is out of bag error? When you are creating a sample from the population, you create sampling with replacement. Let's take a simple example. You have got 100 records. You have to create a sample with replacement having size 100. The records are numbered as 1, 2, 3, 4, 5, ... 100. What is the probability that the sample that you are creating will not have record number 5? The solution to this is, we have number of records as 100. Probability that the record 5 will be selected when I draw one record out of 100 is 0.01. Probability that the record 5 is not selected when I draw one record out of 100 is 0.99. Probability that I select one record from 100 and I do not get record number 5 is 0.99. I make a second draw. Probability I do not get record 5 in my second draw is also 0.99. Probability I do not get record 5 in my first and second draw is equal to 0.99 into 0.99. I repeat this step 100 times. Probability record 5 not selected in all 100 draws is equal to 0.99 to the power 100, which is equal to 0.366. Let us assume we have got number of records as 10,000 now. In that case, the probability of record 5 not getting selected will be probability of record 5 being selected is 1 by 10,000 and probability of record 5 not being selected is 0.999. And now I am creating a sample having 10,000 observation. In that case, the probability of record 5 being not selected in all 10,000 draws is equal to 0.9999 to the power 10,000, and this number comes out to be again 0.367, very close to 36%. What it means is when you have a population, from that population using sampling with replacement, you create a sample which is equal to population size. Approximately 36% of the records will not be selected in the sample. In random forest, first step was sampling with replacement. So when I create a sample with replacement, 36% of records will not be part of the sample dataset. Now the sample dataset is used and you build a classification tree model on it. For this classification tree, the records which are not part of it are called as out of bag records, out of bag sample. With this understanding, let's quickly summarize out of bag error rate. Sample left out in the kth tree is classified using the kth tree. The samples which are left out, those records are classified using the model in which they are not part of it during the model development phase. Assume j cases out of these out of bags are misclassified. Proportion of time that j is not equal to the true class averaged over all cases in the out of bag estimate of error rate is out of bag error. In other words, in a simple way, let me try to explain this. समझ में आया? समझ में आया? तो ये पीछे आउट ऑफ बैग एरर का कैलकुलेशन है, ठीक है? So here we have got the out of bag error rate graph. In this out of bag error rate graph, what you are seeing is as the number of trees in the model increase, my out of bag error is decreasing. After a certain point, you can see out of bag error is actually not decreasing. It is more or less moving up and down at a particular level, which means somewhere here I'm getting the reduction in error. After that, whatever error is reducing or increasing, it is like a chance thing. So optimal number of trees which I require to build my model is to this point. Number of estimators, number of trees in the background should be around 100, 101. Beyond that, you are not getting any reduction in your error rate. Why it is important to find out optimal number of trees required? Why not create 200 trees? Why not create 500 trees? See, if you are going to create 500 trees, a new record, if you have to predict, you will have to first predict the class using 500 classification trees, and then you will have to apply voting principle. It is going to take time. And if the model performance is not going to improve beyond 100, you make 100 trees or you make 500 trees, your model performance is more or less same, then why to increase the time required to predict the class of a new record? That's why you have to find out optimal number of trees required to build your model. And this graph clearly highlights around 101 trees are sufficiently good for our given data set. Having found out the optimal number of trees, I'm now going to create a random forest classifier where you can see number of estimators is equal to 101, which means I'm now saying that when you're building the random forest tree, in the background you should have 101 classification trees. Max depth is equal to 10, min sample split equal to 100, out of bag score true, random state 1 to 1 2. Random state is like setting the seed for creating the random sampling process. So I'm creating this random forest classifier object, and I'm now fitting a model between my X train and the Y train. So this is going to give me a model. Having built the model, I would like to know which variables have got strongest influence in the overall model. To know the variables which have got strongest influence, there is certain piece of code which gives you feature importance. So there is a parameter in the random forest which says feature importance. So we will run this piece of code to get which features are important. Let me try to explain you how this feature importance is calculated. In a simple classification tree, what happens is we create only one classification tree. When we have only one classification tree, the variable which splits the root node is definitely the best important variable. And then the child nodes which get splitted by the next variable becomes important. So logically, one single classification tree directly tells you which variable is important. However, in a random forest, you do not have one classification tree, you have many classification trees in the background. Moreover, variables are selected randomly. As such, you require some approach of finding out which variable is important relative to others. So we have to find out relative importance of the variables. Let us now understand how variable importance is computed. Let us say we are computing variable importance on a particular model performance measure, say accuracy. My way of computing variable importance is using classification accuracy. Step 1, I have my random forest model. And that random forest model has been built using 100 attributes. I am going to score each record using the overall model. I'll get my predicted class. I'm going to take the predicted class, compare it with the actual class, create a classification matrix, find out my classification accuracy, that is the overall model performance measure measured in terms of classification accuracy. Let us try to understand how the variable importance is computed. Step 1, you take actual columns for your prediction of the predicted class. You get the predicted class, compare with the actual target column, create a confusion matrix, you get the error rate. Step 2, one of the columns, in this case let's say age. The actual age of this record is 41. 52, 31, 45. These are actual age. But instead of using actual age of each and every record, I am going to create a new column, age permuted. And based on the distribution of age, I'm randomly going to give the customers age values, keeping all other columns as it is. Using my model, I'm now going to predict the class of each record. Only change is I'm not using actual age, I'm using permuted age. When I use the permuted age and all other columns remaining as it is, and I predict the class, if I now create a classification error matrix, confusion matrix, will my error be higher as compared to when none of the variable was permuted, all variables were taken at their actual values? Obviously, logically thinking, my error should be higher when I permute randomly the values instead of using the original values. So this is what we are going to do, one variable at a time. First, we are going to permute age. Then we are going to permute gender, keeping all other columns as constant as they are. Then we are going to play with balance column, keeping all other columns at their actual values. Only balance values will be permuted. What it means is this customer whose balance is 91,519.92, when I permute, the balance of this customer may become rupee 10 also. And there is another customer who's got balance of 10,791. The actual value may become 1 lakh also. Obviously, when you're going to permute and change the values drastically, the chance of error increasing is higher. So in each iteration, one variable at a time, we are going to permute and we are going to see what is the difference in error rate when the variable is permuted minus when no variable is permuted. This way, for each variable, we are going to get the decrease in error. Once we get that, what we are going to do is normalize it. What it means is, for all the errors which I have got, I will sum it up. That is the total. Then each of them I'll make it in a proportion. Okay, that is normalization is what I'm going to do. Having normalized, these are the steps which are mentioned in the normalization. Sorry. So after having computed the decrease, what you have to do is normalize the parameter with the maximum decrease is the best parameter. So in the table here, we have got the features sorted by their importance. 0.284 is for holding period, 0.167 is for number of credit transaction, 0.1353 is for balance. These numbers by itself does not have any meaning. They have to be interpreted in a relative sense. What it means is 0.284 is more than 0.167, so which means relatively holding period is more important than number of credit transactions. And 0.1673 is 0.1671 is more than 1.1353 of balance, so number of credit transaction in the overall model is relatively more important than balance. And the least important columns are your age buckets column, which are at the bottom, which means age bucket column is least importance in the overall frame of my model, random forest model in this case. If you add up all of these values, 0.284 plus 0.1671 plus 0.1353 plus 0.1208, so forth, the total sum is going to be equal to 1. Having understood the variable importance, let us now see the model performance. Is my model overfitting or not overfitting? To see the performance, we will use random forest predict proba to get the probability score for each and every record. Using this, we first get the probability, and then we are going to compute the AUC, area under the curve. This model performance measure we have already learned in our classification tree technique. So I'll just compute the AUC. My AUC for the model is coming out to be 0.86 on the development sample. I need to see the performance on the holdout sample. All the data preparation that we did on the development sample, which is converting the categorical variables into one hot encoding 1-0 dummy matrix, we have to do on the holdout. So this step is to do that. Having done that, I'm predicting the probability score and then comparing with the actual target to get the AUC. The AUC in this case is coming out to be 0.77. Development sample suggests AUC as 0.86. Holdout, the testing set, suggests that it is 0.77, which means there is a overfit. If your training and testing numbers are not matching, in that case what we assume is there is a overfitting. How to get a reliable estimate of the model performance measure? To get a reliable estimate of model performance measure, we should be using cross validation. So we saw that our model has overfit. Random forest model typically does not overfit as more trees are added to the forest. Why? Random forest models do not overfit because of two reasons. One is variance is reduced by training on different samples of the data. What you are doing is when you are creating samples with replacement, you are simulating many scenarios and you are building many models and then you are averaging it out. When you average out, variance gets reduced. Averaging typically helps reduce variance. Okay. So variance is reduced by training on different samples of the data. Second element, bias is reduced also. How is bias reduced? Bias is induced in a model when you leave out a variable having impact on the target. But in random forest, what are you doing? You're building many models. A particular variable, if it is not part of one model, it is likely that it may be part of another model. And my decision is a collective decision of many models taken together, which means the impact of the variable is accounted for in one of the many models. So random forest, by averaging out, tends to reduce variance. By allowing multiple features to be part of the model, tends to eliminate bias. As such, random forest models typically do not overfit. There are certain diagrams shown here for overfitting, underfitting, and good balance. The bottom two bullet points are very important. Simple model. If you build a very simple model, what it will have is less parameters. If you have less parameters, which means certain parameters will be left out. If certain parameters will are left out, which means your variance will be low, but bias will be high. On the other hand, if you build a very complex model, which means it will be a function of many parameters, and when it is a function of many parameters, you are trying to fit more accurately. In that case, what will happen is it may lead to more variance because now you are trying to overfit using all parameters and you are trying to accurately fit each and every data point. In that case, your variance will be high, but bias will be low. We do not want high variance, low bias. Neither I want low variance, high bias. Something in between is what I want, which is a good fit. Now, how do you find that good fit? The standard approach to find a good fit is cross-validation. You break the data into many partitions. You build model by taking n-1 partition, test in on the nth partition in a given fold, and in subsequent fold you make one of the partition which was earlier part of training as part of testing. This way you do cross validation. After doing cross validation, you try to find out the reliable model performance estimate. So we are now going to see how to find out the reliable AUC for the model that we built. Coming back to the code, to find out reliable parameters setting and accurate model performance measure, we are going to use randomized search CV. In our classification tree technique, we had used grid search CV. Here I am going to use randomized search CV. First point, what I am saying is n estimators. I am creating estimators between 50 to 125 at a step jump of 5, which means I will have n estimator, number of trees in the background 50, number of trees in the background 55, 60, 65, these various combinations I am going to try. Then I am saying try how many features? 2 features, 3 features, 4 features. What are these features? In our data set, how many variables are there? In our data set, we have got 8 variables. What are those 8 variables? Age is one attribute, gender, balance, occupation, number of credit transaction, age bucket, scope, holding period. 8 attributes are there. These, and what we said, the rule is square root. Optimal number of m is somewhere around square root. So square root of 8, that is square root of 9 is 3. So I'm trying 2, 3 or 4. Okay. So optimal will be somewhere around 2, 3, 4. And typically also remember, optimal value of m is usually a range which is quite wide. What I mean by that is, when you are going to run this, you may get the answer as 2, or you may get answer as 3, or you may get answer as 4. If there are 100 columns, 100 attributes, the optimal may be in a range of 8 to 15 something. Sometimes you will run and you will get the optimal as 10. Next time you run the code again, your optimal may come as 12. Why this optimal may change is because when you are doing the random forest model, the samples which are created in the background are randomly created. So some amount of fluctuation will be there, but it will be in a range. It will not so happen one time you run, you get optimal m, number of attributes to be selected, estimators, as 10. Next time you run, you will get 25. It will not be that wide. It will, but 10, 12, 14, that fluctuation will happen. So I am now trying out combination which is features 2, 3, 4. Okay. I am also saying that I want many combinations of min sample split parameter from 100 to 500. Okay, so 100, 105, 1010 and so forth. Let me just run this piece of code. So what are the combinations it is going to give me? Let me first see. If I run this, say, okay, sorry, not 100 to 105, it is saying that 100, 200, 300, 400, 500. So 5 combinations. Likewise for this, how many combinations it would be? 50, 68.7 and so forth. 5 combination. 5 into 5, 25. Max features, 3 max features we are seeing. 2, 3, 4. These combinations. 25 into 3, 75. Okay. I am creating a random grid having 75 possible combinations. If you would have run the code using a grid search cross validation, what will happen? In the background, you will have 75 iterations going on. But what we are going to use is random search cross validation. And in random search cross validation, those parameters we are going to pass, and we are going to say, out of the possible 75 combination, you randomly try 10 combinations, and using random 10 combination, give me the optimal set of parameters. This is the beauty of randomized search cross validation. It limits the number of iterations. By limiting the number of iterations, it still gives you the optimal combination to the best extent possible. So let us run this piece of code. The tuning the random forest parameter is what I'm running, and we are going to tune it using a random search CV. It is going to take some time fitting the model because you are trying 10 combinations, and each of the 10 combinations have a cross validation factor of 10, which means 10 into 10, 100 fits are going to happen. What is this parameter verbose equal to 2? Verbose equal to 2 means out of the 100 fits, display the verbose outcome only for the initial two iterations. If I would have said verbose equal to 100, it would have displayed all 100 iterations here. Okay, so that's the parameter verbose. N jobs equal to -1. N jobs equal to -1. The moment you set n jobs equal to -1, in case your machine has got 4 CPU, parallel processing on 4 CPU is going to happen. If you would have set n jobs equal to 1, it means use only one CPU for the processing, which means it would now happen sequential processing. Okay, so -1 to speed up the processing and use all of the CPUs available in your machine, set n jobs is equal to -1. CV is equal to 10. We are using cross validation factor of 10. Now when you are going to use a cross validation factor, what should be the model performance measure? I am saying use ROC AUC as a parameter, as a benchmark to find which combination is the best combination. There are two possible values you can give. One is accuracy, which will be classification accuracy, and second is ROC AUC. In case you want to give a custom developed model performance parameter, you can give, but in that case some more coding will get involved. Why am I not using accuracy? Classification accuracy parameter. Our data set is an unbalanced data set. For an unbalanced data set, AUC is a right model performance measure. Classification accuracy is not a right model performance measure. For a balanced data set, classification accuracy is a right model performance measure. This is what we learned in our classification tree technique. We used a balanced data set, which was iris. We built a model, and then we used an unbalanced data set, and then I had showcased why for an unbalanced data set we should not use classification accuracy, and that's where we learned area under the curve model performance measure. And this data set is unbalanced, so we are going to continue with AUC as the model performance measure. Okay, our code has got executed. This is the outcome that we have. Once we have got the outcome, we have to see what is the best param. I run that. It says the best parameter is use max features 4, min sample split parameter to be set as 100, and number of trees to be considered, it is suggesting 87 trees to be considered. With that combination, what will be my AUC measure? With that combination, my AUC is coming out as 0.78. I am going to take the best estimator combination in this attribute, and that best estimator I'm going to use for predicting the probabilities on my testing dataset. On testing dataset, then I'm going to compute my AUC. And okay, we have got the outcome. AUC has come around 0.77. Let me use this model which we got here, best random forest classifier. I'm using this best random classifier to predict the probability on my training set. I built the model using cross validation on the entire training set. I'm now using it on the training set and now computing AUC. AUC is coming out to be 0.89. What is the catch here? The catch here is when you build a model on the entire dataset and again you are going to test on the entire dataset, the model performance is going to be becoming higher. So that is not a reliable estimate of the model performance measure. The reliable estimate of a model performance measure you will get only by doing a cross validation approach. As such, this model performance measure which you got using the cross validation has to be considered as your reliable estimate. And when you compare this with the holdout dataset, you can see the two numbers are very close to each other. Okay, so do not try to, after doing cross validation, do not try to take the best classifier, apply on the training set, and then take the model performance measure. That is completely wrong. When you have done cross validation, take the best score using the cross validation approach and check that number with your holdout dataset number. If those two are coming close to each other, you have got a model which is not an overfit model. We are now going to learn another model performance measure which is called rank ordering table and the case statistics. We'll take a quick break, and after the break we'll resume with the rank order and case statistics. Thank you.